Hello, my name is Savanna Larson, and my research project is evaluating and modeling the effects of the ecological process of sympatry on Canada lynx and bobcat population dynamics in Minnesota. As global temperatures rise, we tend to notice changing weather patterns with specifically warmer winters and increased precipitation here in Minnesota as some of the most perceived effects. Humans are not the only species noticing these changes, however. The Canada lynx, which lives in the boreal forests of northern Minnesota, is at risk of a shrinking population due to less habitat available. Lynx fill a very specific ecological niche in their habitat that is subject to negative effects from climate change, specifically boreal forests with deep snow in the winter. Therefore, certain determining factors can be identified to analyze the suitability of a habitat area for lynx and the overall abundance of habitat suitable for lynx. One such factor is bobcat presence. Bobcats are more tolerant of warmer temperatures and are moving into warmer habitat ranges, pushing lynx out via interspecies competition and less suitability of the habitat for the lynx. For the application of this pattern to Minnesota, I designed a methodology that would allow me to determine if the same pattern of sympatry pushing Canada lynx north exists in Minnesota, as there is a lack of studies about this pattern for Minnesota. Firstly, I obtained data for species of interest and covariates that make up biotic and abiotic aspects of their ecosystem. I then did an analysis of bobcat and Canada lynx populations in Minnesota to reject the null hypothesis and prove that there is indeed sympatry using spatial autocorrelation. I then created species distribution models using the MaxENT tool in ArcGIS to predict possible population throughout the whole state of Minnesota to determine where bobcat and lynx would both respectively be found and not be found, and the covariates that affect that. I analyzed these covariates with spatial analysis and the community temperature index. I then suggest areas that should have focused conservation of Canada lynx. Based on the establishment of sympatry of Canada lynx and bobcats in the state of Minnesota, I created species distribution maps using the MaxENT tool in ArcGIS. MaxENT takes a few training covariates and presence points of a specific population to predict where else on a given raster or combination of rasters there would likely also be an existing population. After obtaining Canada lynx data from the MNDNR and bobcat data from iNaturalist, I created species distribution maps for each with MaxENT and habitat type being the training raster. I then compared these maps to other factors that affect Canada lynx populations, such as snow depth and temperature. Overall, Canada lynx were more clustered in areas of Minnesota with mean snow depth greater than 5 inches and a stable snowshoe hare population. Bobcats were also found to occupy these same areas, supporting the idea of sympatry between Canada lynx and bobcat populations. The versatility of bobcat populations is shown, however, with their greater presence in the MaxENT model, shown with the light yellow dots, as opposed to a more clustered estimate of Canada lynx in the north part of Minnesota, shown in blue dots. Upon further evaluation of the effect of temperature on Canada lynx populations using CTI, I found that the ideal temperature of the Canada lynx and snowshoe hare trophic relationship was 4.5954 degrees Celsius. I was also able to get graphs from my model to show the effect of each habitat type on the prediction of Canada lynx or bobcats by my model. So figure 3 shows that for bobcats, developed areas and evergreen forests result in the highest probability of presence, and figure 4 shows that for Canada lynx, developed areas, shrub, and evergreen forest result in the highest probability of presence. As Canada lynx are a federally threatened species in the United States, it is vital that conservation practices are implemented before it is too late and they become endangered or locally extinct from Minnesota ecosystems. It is even more so important that Canada lynx are protected because they occupy a position as the apex predators of the northern Minnesotan ecosystems, and their absence may lead to an ecological trophic cascade, or specifically negative effects on the ecosystem, such as an abundance of their prey, snowshoe hare, which would lead to the degradation of local vegetation. Therefore, based on my MaxENT models, I identified a few key conservation opportunity areas where conservation efforts should be focused in order to protect Canada lynx populations. So Area 3 on the map is the St. Louis River headwater, Area 4 on the map is the northern North Shore, and Area 5 is the Lutsen Highlands. These are conservation opportunity areas as identified prior by the MNDNR, but conservation opportunity areas should also be implemented in areas 1 and 2 to make sure that Canada lynx populations are protected fully. Providing conservation for Canada lynx habitat is only one step of their conservation, however, as warming temperatures and a lack of adequate snowfall is something that cannot be addressed through habitat conservation and must be addressed at the larger scale of prevented climate change. Recommended steps for the conservation of Canada lynx, therefore, include targeted conservation of Canada lynx in conservation opportunity areas, as well as a larger climate policy to decrease rising temperatures and a lack of snowfall depth that negatively affects Canada lynx. Non-governmental organizations, as well as state organizations such as the MNDNR, should work together to create an all-encompassing plan to protect Canada lynx, and everyone should be mindful of their carbon footprint and spread the awareness of the impact of climate change affecting Minnesota as to ensure Canada lynx are protected as one of the greatest cultural and ecological species of Minnesota. The next steps for my project include improving the accuracy of my models, so mainly there are errors from the data collection methods as species are predicted to live closer to human settlements, but only because of the data collection methods where citizen scientists were more likely to identify the species closer to human settlements. In addition, I would like to increase the number of covariates that I'm using to train my models in ArcGIS. And additionally, I would like to explore possible action plans for conserving the Canada lynx at a Minnesota statewide level that will be able to ensure Canada lynx do not become regionally extinct in the state of Minnesota. Thank you.